reflect to right hand. Are you catch my point, friends? Here the optical isomerism is the nothing but here reflect to images. For example, this is the structure of what? Optical isomerism. So what's friends? Not only all the substituents, it can arrange to only some substituents atoms, sir. It is the protective and the reflect some bonds. So this is the structure of optical isomerism. So this is, so here all substituents are rotated? No, only substituents and rearranged to given branched carbon chains coming off the main chain. But the name of the molecular formula is still the same. So here also same, only some substituents and common shares. So okay friends. So this is the structure of optical isomerism. So friends, here we can learn what is the uses and we can learn what is the structure. Butane converts to but1ene and butane converts to 2-methylpropane and cyclo converts to. So this all the structures we can change, but actually here we can must and should concentrate on 1,2-dichloroethane in geometrical isomerism. So friends, here the geometrical isomerism already you learn a lot. So here the 1,2-dichloroethane converts to 1,2-dichloroethane. Already I will tell. So here it is the possible what commonly exhibited by the alkanes, the presence of two different non-superimposable isomers, because that is the restricted rotation of the bond. So it is the point of, okay friends, all the molecules not only restricted rotation of the bond in the double bond, it is the geometrical isomerism. So friends, this is the matter. So friends, already you learn what is the uses of 1,2-dichloroethane, what is the uses of 2-methylpropane. So already I will give the live example of that PVC pipes, sprays and the lot of uses of there. So friends, this is a very important topic now. So are you sure here? So friends, here I will give another example of geometrical isomerism. Already you know what is the definition of geometrical isomerism. Friends, here you can must and should concentrate on only geometrical isomerism. Okay, are you sure friends? Means here this is the nothing what commonly exhibited by the alkanes, the presence of two different non-superimposable isomers, because of they have the different types of isomers and the properties also. That's why we can change one to another, but they are not restricted rotation because they can have the double bond. That's why they are the not rotated bonds, only that are the singles and that has the not rotated bonds. So friends, here for example butane. Butane already you know, this is the very simple question. So for example, we take butane. Already you know why we call as the butane here. Why? For example, here the C4. How many hydrogens? 1, 2, 3, 4, 5, 6, 7 and 8. Why we called butane means here the cis. We can take the double bond in front of second atom. That's why we call as the butane. So it converts to what? 4 carbons. How many hydrogens are there? 1, 2, 3, 4, 5, 6, 7 and 8. Here the position isomerism is also important and it refers to the name of the molecule changes to reflect this and the position of the molecule changes to reflect this, but the molecular formula still the same and the name of the position also still the same. What? Butane converts to but1ene. So here we can put double bond in front of first carbon, that's why we call the but1ene. Here we can put double bond in front of second carbon, that's why we call as butane. So friends, here this is the but1ene, butane, nothing but the position or molecule adjust to rearrange the molecular formula same. Here means how many carbons are C4, H8. Here also molecular formula C4, H8, but it's changed to position. Yes friends, here we can put double bond in front of second bond. Here we can put second double bond in front of first carbon, but it can change to name. This can change to position only, but it refers to the same molecular formula and the structure also same. We can changes. Here we can have any changes for it? No. How many hydrogens? 1, 2, 3, 4, 5, 6, 7 and 8. Here same 4 carbons and 8 hydrogens, means here it can refers to only say the position of the molecule changes and reflect the position, but still the molecular formula same and the structure also same. This is the position isomerism. Are you sure friends? Okay friends, are you sure? Means here, hello friend.
Hello, sir.
Hello, hi Swaro. What is your name?
Hello, I am Ashok, studying first by DC,
Okay, friend.
and I am from Palwan, sir.
Okay, ask your
So my
doubt.
question is that formula and structure of vinyl chloride.
What, friend? Okay, repeat.
Formula and structure of vinyl chloride.
Oh, exactly. This is a great question, friend. Here, the 1,2-dichloroethane is C2H2Cl2. Here, the C2H4Cl3. Okay? Clarified, your friend? Thank you. So, yes, we are the very busy now. So, while late, we can discuss about the what? Yes, the position isomerism. These are the clarified and this is the okay. So, next one is the chain. So, here the position is the nothing but we can change the what? You can only reflect the name of the functional and it changes to the position. But here the chain isomerism is the nothing but it is rearranged to given branched carbon chains coming off the main chain. But the name of the molecule changes to reflect the new position. Yes, exactly. So, what? For example, butane. Are you following, friends? So, butane, what? 1, 2, 3, 4. What is the chemical formula? C4H8. Okay, friend. So, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So, this is the formula of butane. So, in the chain isomerism, what converts to here? This is converts to. So, friends, here the C4H10 means if we can change the name of the molecule changes to reflect the new position. So, here the butane converts to how many carbons are there? 4. Observe it, this is the main important. So, how many carbons? How many carbons? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Are you sure, friends? Here the name of the molecule changes reflect the same. But its position, we can change only position. No, it can change to. Hello, friend. Hi, Swaro. Hi, Swaro. Okay, hello, Swaro. How are you?
Hello.
Hello, what is your name, friend? What? So, here this is we can change the butane cyclobutane. It is possible, friends. Yes. Why we cannot possible here? We can change to butane in cyclobutane. Why we call the cyclobutane means here this is the cyclobutane structure. That's why we call butane converts to cyclobutane. Means we can change. Already I will tell this is the possible what we can convert to anything for any years to geometrical isomerism. I think you are very sure in this chain isomerism. Okay, friends. Already you know what is the definition of chain and what is the examples of chain and you know what is the position, what is the functional and what is the definitions and what are the examples are that. Already I know you are still and you know what is the stability and you know what is the properties of in physics means physical properties are there. When in the for example cis, here the cis, here the higher in melting point automatically boiling point is lower in trans. Here the higher boiling point means automatically melting point is lower. So, here cis how the higher melting point automatically converts to lower boiling point. Are you sure, friends? So, here the cis and trans the physical properties is the nothing but here for example cis they have the more molecular formula but the chance to convert to rearrange and it is given to more stability and this is the one thing what the cis isomers stronger than the trans isomerism because the cis is the nothing but you have the U-shaped ion that are very stronger. That's why here the cis and trans the cis isomerism is stronger than the trans isomerism. Are you sure, friends, here? Okay. So, friends, already I will tell we can discuss about geometrical isomerism and it is very important for us. So, friends, you can ask me anything means friends here the nothing but I think I talk anything you can observe here. The what? Here you know what is the stability and the what is the properties of physical properties means here the physical properties and stability all we know. But actually we can change to 2-methyl propane to already you know what is the structure sign there and what is the chemical formula there. but we can change one to another. But in this geometrical isomerism, we can change anything? No, Spheros, exactly, you are great. So, geometrical isomerism. So, here for example 1,2-dichloroethane. 1,2-dichloroethane converts to only 1,2-dichloroethane. How it is possible? Yes, commonly excited by the alkanes. The presence of two different substituents on both carbon atoms, but at the end of the double bond it can give rise to two different non-superimposable isomers because they can have the restricted rotation of the bond. Hello?
Sorry. Hello?
Okay, hi Swero, what is your name?
Hello?
Okay, hi Swero, what is your name?
Hi, my name is Deeksha. I am from Bignur.
Okay, decrease your volume, Swero.
Hello?
Okay, what is your doubt?
Hello?
What is your question? Swero, I am ready to now clarify your doubt. Okay, decrease your volume and next ask your question. So here, what? Okay, you are now very interesting topic now. So 1,2-dichloroethane converts to 1,2-dichloroethane. So you can ask me friend, already I will say the 1,2-dichloroethane converts to 1,2-dichloroethane. Here they have the double bond and it converts to only double bond. Here we can observe one thing, what? The cis isomerism converts to trans isomerism and trans converts to cis isomerism. But here friends, here the 1,2-dichloroethane converts to only 1,2-dichloroethane. How it's possible friends? Means here this is the very stronger. The geometrical isomerism is stronger than the all because of here the commonly exhibited by the alkanes, the presence of two different non-superimposable isomers and that are restricted rotation of the bond because they can have the different properties of this. So friends, we can go the first. Already you know what is the definition of both. So friends, first you learned so many things today. So friends, here already you learned so many things, means what is the isomers? Okay, isomers are the nothing but that are compound that have the same molecular formula, right? And that are restricted rotation of the bond. It can give rise to two different non-superimposable isomers and because they have the double bond. So friends, here the geometrical isomerism. So today we learned so many things for this geometrical isomerism and I will show what is the different properties and what is the chemical properties and how can it useful to in our daily life. So friends, what is the isomerism? Isomerism. What is the isomerism? Okay, Sveros, I will tell once again. So geometrical isomerism is nothing but. Hello?
Hello, I am Pawan Kumar from JP Nagar.
Okay, Svero, what is your
Hello.
doubt?
Why the systems have different boiling and melting point stability?
What friend?
What is the reason?
Ask clearly friend.
Why the systems have different boiling and melting point?
Okay, exactly. It's a great question, Svero. So you are very brilliant.
What is
okay.
the reason?
Okay, I will sure. Here, what is the difference between melting point and boiling point? Here, already I will say the cis isomerism stronger than the trans isomerism. Why? Here, for example, 1,2-dichloroethane friends. Are you sure? Means this is the trans. So here, this is the not U-shaped and this is the not same connectivity. That's why here, this is the not restricted and not covered on the spot. Means for example, Cl one side and hydrogens are one side. Here the U-shaped and stronger than the trans. That's why here the cis have the melting point automatically lower in boiling point. So in the trans have the boiling point automatically decrease the melting point. So this is the difference between melting and boiling points. Are you sure friend? Okay sir, a good question. So next we can go our topic. So what? Yes, here the geometrical isomerism. Friends, you can learn so many things now. So friends, here the GI, the nothing but geometrical isomerism. Already you know friends, here the compound that have the same molecular formula but that are structurally different in some way and it is able to recognize the different types of isomers and here they can have the lots of uses via the structures, and we change the structures. So here friends, the geometrical isomerism, here this is the restricted rotation, but it is not converts to one structure to another structure. So last one is in geometrical isomerism, EZ configuration. Here the EZ nomenclature is the nothing but, for example, here the E means cis is called as E and trans is called as Z. Why we called as here the EZ is based on only CIP system. What is the full form of CIP system here? The C is con Ingold Prelog system. So the EZ nomenclature based on CIP. What is the full form of CIP friends here? CIP is nothing but con Ingold Prelog. So here the CIP based on and depends only con Ingold preunity system. So this is based on which has the higher preunity. For example, one side to chlorine and one side to hydrogen. So which have the higher preunity? So is called as E configuration, and which is the lower connectivity have to called as Z configuration. So EZ is nothing but as like cis and trans isomerism. So here you can observe anything. Cis means you can the same side is called as cis. So automatically here the higher preunity is called as E configuration, which is the opposite and across adjacent is called as trans. Automatically Z configuration is they have the left side. So anyone here the E is the right side and Z is the left side. So here the E is nothing but cis isomerism and trans is nothing but Z isomerism. So it is sure friends, okay. So here the cis and trans and EZ nomenclature is nothing but that is the geometrical isomerism. We can change, we can give the preunity based on higher atomic number. So here we can change the atomic number means. So for example, what is this? Are you sure this? Yes, this is the nothing but, for example, okay, this is the trans. Yes friends, are you sure? Why trans? This is the across, means opposite side is called as trans. Are you sure friends? Here this is the trans. Why? This is the opposite side are called as trans. So cis is nothing but this is the cis. Are you sure friends? Here which have the same side is called cis and which is the opposite side are called trans. Are you sure friends? Here and which is the E and Z nomenclature? Is this is the E? This is the E. So exactly this is the which have the same side and we can give the higher preunity based on this. That's why we call as E nomenclature. And this is the trans. We can give the lower preunity to based on CPI system 2 is the trans, and this is the Z configuration. Are you sure friends? Okay, this is the cis and trans. So friends, here cis and trans and E and Z is nothing but based on CPI system, con prelog system. So here this is the based on CPI. Okay, so this is the trans and cis. So let's we discuss about properties of geometrical isomerism. So already you know what is the uses of geometrical isomerism. So here the properties of geometrical means already you know what is the melting point, what is the higher boiling point. Here when in the cis they have the higher melting point, automatically lower boiling point. In the trans they have the higher boiling point means automatically melting point. So this is the difference between in geometrical isomerism. So friends, are you sure? Okay, are you following me? Okay friends, here for example, CH3, CH3, C2H5, C2H5. So this is the cis or trans. You can observe this friends. What is the structure of this? What is the name of the structure? This is cis or trans. Yes, exactly. This is the trans. Why we call the trans? Yes, these are the opposite side and across. That's why we call as trans. For example, CH3, CH3, the same side is called as cis isomerism. So CH3, CH3 and C2H5, C2H5 opposite side. That's why we call as trans isomerism. So friends, this is the trans isomerism. So we can give higher preunity to same side. So that's why we call as Z configuration. Okay friends, are you following me? Okay. We can give higher preunity to which have the atomic number based on in higher position. That's why we call as Z configuration. So here this converts to cis means this is the E configuration. Okay friends, this is the another example of what is the transit sign E Z nomenclature. So here for example friends, CIP, this is the EZ nomenclature based on CIP means that is the name of any, yes exactly, you are very brilliant. This is the three are scientists. What is the name of first scientist? Kahn, second Ingold, and third one is Prelog. So these are three scientists are exactly depends to the both and cis and trans and E and Z nomenclature. So these are three the scientists of EZ nomenclature. So friends, you learn so many things and what is the uses. We can change one structure to another structure means and what is the use of that, and you can learn lots of uses and lots of information of by the geometrical isomerism. Yes friends, I am sure. So friends, the means this is we can change the one structure to another structure means automatically that is the important and able to recognize the different types of isomers. It is right friends. Okay, means we can learn so many things and we can learn so many uses. So by this geometrical isomerism. So special thanks to my great beloved secretary sir, R.S. Praveen Kumar sir garu, thank you. Thank you sir giving this golden opportunity for me, and my dear principal sir Shri Ashirvadam sir garu giving this golden opportunity for me, and my guide teachers Swapna madam and Sharda madam and my all the staff in my institution, thank you giving this golden opportunity, especially my parents also, thank you. Jai Bhim, Jai Sparrows.